Yo, what's up, everyone? Good morning. Welcome back. Week 4. Only a few weeks left of the year. And this is going to be our last logarithmic solving worksheet. And then we're going to do graphing from here on out. So I think we all kind of like the graphing now, which is good. Um, we're solving logs. There's a lot of examples here, I know, but each of them is pretty simple. And then we're doing trig for the last few weeks of the class. So week 4 and week 5, we'll have a quiz after next week. Um, and then whatever the last 4 weeks are going to be trig. So today, again, it is a lot of questions, but they're all kind of simple. And the big thing that we're trying to get used to is solving equations again. And the big reason for that is that when we solve a graph, or not solve, but when we have to do a graph, we know that a graph is an equation, right? With both an x and a y. So we're going to have to start getting used to looking at these. We'll start with something that's really simple. And I should say, like, just solve for x in each of these equations. But for number 1, it says log base 2 of 128. And all I want you to notice or recognize when you see this is that this is called an expression, not an equation, because it doesn't have an equal sign. But we know that when we're solving this, we're like figuring out what this is equal to, right? And I know what I just said doesn't sound like it makes a lot of sense, but if you look at 1 compared to 2, both of them, you're solving the same thing. You're trying to figure out what is this log equal, right? So if it says equal x, or whether it doesn't say equal x, you're just solving for this equation, right? Um, so that's that. In this case, we're looking for 2 to what power gives me 128. And hopefully at this point you have your strategies down. And you can even understand the smaller ones, but 2 to the 7, right? You can do something like this, keep going until you get to the number of 7s it is. So we know that this log equals 7. For the second one, what I was saying before is that you're doing the same thing. You're trying to solve this log and figure out what this log is equal to. The x is already isolated. Because remember, whenever you have an equation, you want to have the x, or the variable, by itself. So that's important for the next two. But here, same thing is going on. We're trying to figure out 9 to what power gives me 729, which is going to be 3. So x equals 3 here. You don't have to rewrite it, but remember that this is all the log is saying. It's one of these exponentials. The base number raised to the other side's power equals the top number. Good. So now x is going to be on the same side as my equation. So what we have here is log base 5 of x is equal to 4. And for the next few examples, this is really important just to focus on what this means, right? It's saying that our base number is 5, and the other side tells us the exponent. So this is saying 5 to the 4th power equals what? The big number is always on top of the log, right? So it's going to be a big number because it's 5 to the 4th, right? If we wanted to rewrite this, we can isolate x, or get x on the side by itself, by converting it to an exponent, right? So that's what makes logs so useful, is it's just another way to write this kind of equation. So again, as long as you understand the relationship between the two of these, like, you're going to be able to solve everything, right? 5 raised to the 4th is equal to this top number. So 625. Four is a little harder. And again, another thing to recognize is that this is like actually the form that we're going to graph. Okay, so start getting used to seeing x in the equation. Because here, just as a side note, what we're building towards is that this could be an equation, right? Y equals, but I'll cross it out for now to not confuse you. This one, let's solve. And here we don't know the base number, right? We don't know what number is being raised to the fourth power to give me the number over here. And we can rewrite this, and it's gonna not isolate my variable, but it's gonna get us a little closer, okay? So if you ever see a base number that is the x, what makes that difficult is that you could try to simplify this. So we know it's x to the fourth equals 81, but we still have an isolated x, right? So from our last unit, hopefully remember, I mean, this is actually new, but all this means is what to the fourth power gives me 81. If we wanted to, solve this or isolate it, we could take the fourth root of this whole expression. That cancels out that. And we take the fourth root of 81, which, is all we were doing from the front. So this doesn't even necessarily help, because all this is saying is what number 4 times gives me 81, okay? But that would be the mechanism for solving. But what I was going to say is that this is one of those that maybe you should just do in your head, right? It's going to be some number to the fourth power gives you 81. We know that 81 is a number related to 3 and 9. So if we try 3, it gives us our answer, okay? So this is x equals 3. Let's approach a few more of these. And we're just going to see how easy it is. Log base 8 of x is equal to 5. Here, we can simplify to isolate, so it's pretty easy. And we're just looking for 8 to the fifth power. So x equals 32 and change. These are a little harder because we know it's x to the fifth gives me 243. And I go through the end kind of quickly, but hopefully you remember or realize, like, you can always experiment with these small numbers. So I tried 7 to the fifth. The number got way too big. But maybe I remember that this could be another 3. So it's going to be 3 to the fifth. Okay, so you're just kind of trying to figure out what number to the fifth power gives me 243. But those are kind of like the hardest in terms of like solving at the last step, right? We could take the fifth root of this number, but you're still trying to solve the same thing. Okay, good. So that's kind of the most important part, but now we're gonna do number 7, which, in the past, I would have spent a day or two longer kind of messing around with these equations. This year I decided it wasn't too important. I'd rather do some trig. But all that's different between this and what we just did is that our x is now part of something larger, right? So this is 2x, okay? But that's not going to change fundamentally how we solve this. It's going to be still this number to this power gives me this number. So let's do that step, but it's not going to give us x, it's going to give us 2x, right? So 10 to the third power equals 2x. 10 to the third is going to be 1,000, right? 10 times 10 times 10. This always tells you how many zeros there are, which is the shortcut. And, this didn't add any complexity because we can just divide both sides by 2 now. So we're going to get x is equal to 500. So hopefully that makes sense to you. This could get infinitely trickier, and this one will be a little harder than the last one. But it's not going to make it killer, okay? It's just going to add some algebra at the end. Here, let's kind of isolate the same way. 2 to the 4x is equal to 256. And, this is one that we're going to just do a side to figure it out. Hopefully what you can think is 2 to what power gives me 256. And then whatever that is, we can just kind of, divide by 4 to figure out what this is going to be. And what I mean is that it's going to be 2 to the 8th, right? So 2 to the 8th, crap. 2 to the 8th equals 256. So that means that x has to be 2, right? 4 times 2 gives me 8. So x is equal to 2. Okay. Excellent. So I would call that part 1 of this example, and this is part 2. And this is something that you could spend a month longer on, but we're going to just do very, very quickly. And that's what we do if we don't see a base number. Okay. So if you have further along in math, if you take my class next year, we're not going to do more of this probably. But if you took, I guess, calculus or college math, you might see logs without a base number pretty often. And what that means is there's an implied base number. Okay, so that's the first thing to recognize. This question, we see log base 10 of x is equal to 3. Very similar to the ones that we did before. We know that it's going to be 10 to the third is equal to x, which makes x equal 1,000 here. And maybe this isn't even properly explained, but the big idea is that the implied base number, if you don't see one, is 10. Okay, so let's say there wasn't a base number here. Let's just say it said log of x is equal to 3. You might think, well, that doesn't even make sense. There has to be a base number. But think that it's like the implied number. There's always an implied number in math, right? If something just says x, we know it's x to the first power. And there's no coefficient, so it's just 1x, right? If you just see log x, we need to think is that that's saying log base 10, okay? So log x equals 3, x equals 1,000. That is the answer to this log. And anytime you don't see the base number, we just see log of 1,000. If it helps you, you can put in the implied base number. Okay, so we never do notes really, but that would be called the implied base number. We won't do too much of this, but it's going to help us a bit with graphing. Here, we'll figure out the answer is 3. It's like the same question as number 9, but log of 1,000. If you just saw that, and even if you just put that in the calculator, you may have noticed that you could use log, but there's no base. The implied base number is 10. So here, let's just do 11 and 12. This says log of 1,000,000 is equal to x. So what this is really saying is 10 to what power gives me 1,000,000. Do you guys see what I'm saying? The implied number is 10. So 10 to what power gives me 1,000,000. There are 7 zeros here. So this is going to be 6 zeros. Here we see log x equals 4. And that's just like that first example, right? There's no implied number, or there's like no base, so it's implied that it's 10. So think 10 to the 4th is x, so x is going to be 10,000. This just telling you pretty much how many zeros there are. Alrighty, really good work. Hope that was not the worst lesson, and we get to graphing next time. Great job. Appreciate you. Proud of you.